What really happens to your fat cells when you walk just 30 minutes a day? No running, no gasping for air, no pain? It almost sounds too simple to trigger real change. And yet, behind this simplicity lies one of the most powerful biological programs the human body has ever developed. For a long time, we were taught that fat loss has to be exhausting, that it requires suffering, that only extreme effort leads to real results. But science tells a different story, a quiet story. It unfolds deep inside your cells, where sustainable change is not driven by stress, but by stability maintained over sufficient time. This video is not about motivation, not about calories burned. It is about what truly happens inside your body. Why 30 minutes keeps appearing as a metabolic threshold. Why insulin drops without extreme dieting. And why fat is only released when the body feels safe. The moment your foot touches the ground, your body does not wait. It responds immediately. From a biological perspective, the transition from rest to movement is a signal of urgency, but one that is processed with remarkable precision. Heart rate increases slightly to transport blood more efficiently. Breathing deepens to take in more oxygen. The nervous system directs energy, specifically to the working muscles. All of this happens almost unnoticed, without pain, without alarm, without a sense of stress. At this stage, the body prioritizes safety and stability, not fat loss. Contrary to a widespread myth, the body is not burning fat yet. It first relies on the fastest and safest energy sources available. Glucose in the blood and glycogen in the muscles are mobilized, like turning on nearby lights before starting the generator. That's why the first minutes of walking often feel effortless. The body is in a gentle transition mode. At the same time, the sympathetic nervous system is lightly activated. A small amount of adrenaline is released, not enough to create stress, but sufficient to increase alertness and cellular responsiveness. This is not a fight or flight state. It is more like a soft biological awakening. Many people misunderstand this phase. They think, if the body is still burning sugar, walking doesn't do anything. But the opposite is true. The glucose phase is not an obstacle. It is a necessary preparation. By using quick energy first, the body buys time to stabilize hormones, enzymes, and blood flow. Only then can fat be released safely and efficiently. Here, the liver plays a central role. It releases glucose into the bloodstream in a controlled manner to keep blood sugar stable and ensure the brain is continuously supplied. That's why gentle walking rarely causes dizziness, even in a fasted state. The brain is always prioritized. Subjectively, this phase feels pleasant. Breathing deepens. The body warms up. Mental clarity increases. From the outside, everything looks simple. Inside, the metabolic foundation is being laid. Once walking reaches a steady rhythm, the muscles do more than just consume energy. They begin to communicate. With every rhythmic contraction, they release signaling molecules, so-called myokines. These are not classic hormones, but biological messages sent through the bloodstream to the liver, fat tissue, and brain. The message is clear. The body is in stable motion. Energy demand may soon exceed quick reserves. The most important recipient of these signals is fat tissue. Myokines do not demand immediate fat release. They simply say, prepare yourself. At the same time, another crucial change occurs in the background. Insulin levels begin to drop. Through muscle contractions, muscle cells can absorb glucose without relying heavily on insulin. The need for insulin decreases, and so does insulin in the bloodstream. Why is this so important? Insulin is the lock on the fat cell. When insulin is high, fat remains stored. When insulin drops, the lock begins to open, not by force, but through the right conditions. Fat cells are not passive storage units. They are highly sensitive to internal signals. When myokines are active and insulin is low enough, enzymes inside the fat cell are activated, especially hormone-sensitive lipase. Triglycerides, the stored form of fat, are broken down into 3 free fatty acids and 1 glycerol molecule. From this moment on, energy is no longer trapped. The fatty acids leave the fat cell, enter the bloodstream, and are transported to tissues that need energy, primarily the muscles. This process is calm, controlled, slow. Walking does not create an emergency energy demand. That's why fat is released without stress reactions. Fat cells do not disappear. They shrink like a balloon slowly losing air. That's why fat loss does not happen overnight. But the body has a biological memory. When lipolysis is regularly activated under safe conditions, fat cells become more cooperative over time. Once fatty acids reach the muscles, the decisive step begins: entry into the mitochondria. Mitochondria are more than power plants. They decide whether fat is actually used. This is where beta-oxidation takes place, the process that converts fatty acids into ATP, the cell's energy currency. Walking creates ideal conditions for this. Energy demand rises moderately. Oxygen supply is stable. No stress forces the body back to glucose. Fatty acids provide significantly more ATP than sugar. That's why walking feels sustainable, without energy crashes. Even more important, efficient beta-oxidation sends feedback signals. Insulin sensitivity improves. Inflammation decreases. Metabolic flexibility increases. Over time, the body adapts further. It creates new mitochondria, a process called mitochondrial biogenesis. More mitochondria mean greater fat-burning capacity, better oxygen utilization, more stable energy. 30 minutes is not an arbitrary number. During the first 10-15 minutes, glucose dominates. Between 20 and 30 minutes, the body reaches a state of stable oxygen uptake, the so-called steady state. Heart, lungs, hormones, and metabolism work in sync. Insulin remains stably low. Glucagon and adrenaline rise slightly, supportive, not stressful. At this moment, the body chooses fat as its primary energy source, not abruptly, but as a logical consequence. When this state is reached regularly, the body learns this pattern. The switch to fat burning happens earlier, more efficiently, without resistance. A common myth says, fat melts, is sweated out, or disappears as heat. Reality is more precise. During fat burning, the carbon atoms of fatty acids bind with oxygen. The result is carbon dioxide and water. Most lost fat leaves the body through breathing. With every exhale, CO2 leaves the body. And that CO2 was once fat. Sweat is mainly water and electrolytes, not a measure of fat loss. The calm, deep breathing during walking supports this process perfectly. In the long term, regular walking even changes gene behavior in fat cells. In inactivity, many genes promote fat storage and inflammation. Fat cells become defensive. Through regular movement, the internal environment shifts. Myokines, low insulin, and fat burning signal safety. Genes responsible for fat storage are downregulated. Genes for fat breakdown and transport become more active. Inflammation decreases. Fat tissue becomes metabolically healthier. After about 30 minutes of rhythmic movement, the brain also responds. Serotonin and dopamine increase, not abruptly, but steadily. BDNF, a growth factor for nerve cells, is released. It supports learning, memory, and long-term brain health. Inflammation decreases. Insulin sensitivity remains elevated for hours. Hunger hormones are regulated more stably. The result: less impulsive eating, more control, clearer energy. 30 minutes of walking is not a small stimulus. It is a powerful biological signal. From glucose to myokines, lipolysis, beta-oxidation, CO2 release, gene adaptation, and brain and hormone regulation, each step prepares the next. The body is not forced, it is invited. And when this invitation is repeated daily, change becomes the new normal state. If this video opened new perspectives, leave a comment. And subscribe to the channel if you want to dive deeper into the science of fasting, insulin, and metabolism.